Welcome to my presentation. In this presentation, we shall see how to represent a tangent line to a graph of a function. Calculus is a branch of mathematics that studies the rate of change of functions. Let us understand this tangent line to a curve by a simple graph of this nature. In here, we're looking at a parabola. In this particular graph, the parabola is rising from point x1 y1 to point x2 y2. At the peak or the vertex point x3 y3, the graph levels off, and at point x4 y4 on this parabola, the graph is falling. To determine the rate at which the graph rises or falls at a single point, we find the slope of the tangent line at that point. As you can see here, I drew some tangent points as green lines. So the tangent points at x1, y1 are represented by the green line. Tangent point at x2, y2 is represented by the green line. Tangent point at x3, y3 is represented by the green line there. And then at the tangent point at x4, y4 is represented by the green line there. In simple terms, the tangent line to the graph of a function f at a point P x1, y1 is the line that best approximates the graph at that point, as shown in this figure, where we are seeing the figure which is the parabola. The other examples I can explain here are as follows. We have in this first figure here, I'm going to state this as figure number 1. In this first figure, we're looking at a parabola. The tangent point to at the peak of the parabola, if we call that point as P, that is how we can represent the tangent point. And if the function is represented by y equals to f of x, that is how we can represent the tangent point. In figure 2, if the curve is of that nature, and if we were to pick a point on the curve, and if the function of the curve is represented by y equals to f of x, the tangent point at a particular point on the curve, if we represent it as p, we can represent the tangent as shown there. Tangent point is a point which is just touching the curve at a particular point. On this third figure here, the curve is represented by y is equal to f of x, and the point P is the tangent point for the curve. So this is how we can represent the tangent line to a graph of a function. In my next presentation, we shall see how to represent the slope of a tangent line using limits.